Hello and thank you for attending this demo of Solid Edge Cam Pro. My name is Jim Wright. Let's get started. You know, there are a lot of cam systems out there and they all want you to buy their product. So it can be a difficult choice about which cam system to choose. They all claim to be great, or they have some type of competitive advantage that they think you need to be aware of and to take advantage of. But can they do the job? That's the really consistent worry that we need to worry about. It's enough to make your head spin. So let's take a look at some of the different cam systems and how they stack up to Solid Edge Cam Pro. We think there are three things you should look for in a cam system. The first thing is the capability to do the jobs you have now. The second thing is the capability to grow as your needs grow. And of course, you need this at a manageable cost. Let's see how Solid Edge Cam Pro can fill your needs. What about Amazing Cam? They offer high-speed machining functionality. The code name for this functionality is called AmazePath. They claim that only we have it. However, it is not included. It is an expensive extra cost option. In reality, almost every cam vendor has this new high-speed machining toolpath today. Whether they call it AmazePath or Pathomorph, it does the same thing. It makes the cutting go faster while the cutting tool lasts longer. In Solid Edge Cam Pro, we have adaptive milling, and that's included with any 3-axis package at no extra charge. This is truly world-class technology. It also features things like bottom-up cutting and safe pillar removal. You can use it in 3-axis and 2.5-axis milling for much better results, faster machining, and your cutting tools last longer. Adaptive roughing is a high-speed machining toolpath that makes the tool last longer and yet makes the cutting go faster. It does this by strictly controlling the amount of material that is removed on each pass. Here we've changed the step over amount and now we're regenerating the toolpath. Adaptive roughing also works great on complex geometry, as we see here. First we take a pass at the deepest level that the tool can cut, and then we do bottom-up cutting and go back and remove the excess material that was left after the first cut. This method takes advantage of the full cutting length of the cutter, but also makes a very good consistent amount of stock left over for the semi-finish and finish passes. The pillar cutting option gives you a safe way to remove excess material, not like breaking it off here, but actually turning the pillar into a pile of chips by machining it from above in a spiral method. So here are a few questions that we have for Amazing Cam. Why isn't your AmazePath free? Can AmazePath safely handle pillar cutting? Can AmazePath handle bottom-up cutting? Cheap Cam has limited options for machining complex geometry. They may suggest something like cross-hatching, which is a zigzag pattern repeated at 90 degrees. Now there's a problem with this. If you're working with certain materials like titanium, recutting is very bad. In other words, it might cause work hardening. It also takes extra time. Also, crosshatching will not work on a combination of steep and non-steep geometry. In reality, steep geometry, which is surfaces that are close to the spindle axis or parallel to the spindle axis, must be machined differently than non-steep geometry. Let's see a demo. There are several distinct problems with crosshatching. First, it wastes machine time and money because you're going over the surface twice when you don't need to. Secondly, certain materials, such as titanium, don't take well to being machined a second time. And third, crosshatching doesn't really work on steep geometry, as you'll see in this demo. For crosshatching, to get a good surface on steep geometry, you have to place the stepovers very, very close together. And that means the surface finish on the non-steep geometry is kind of overkill. However, if you make a nice surface finish on the non-steep geometry, then the steep geometry will not have a good surface finish on it. It'll be too rough, too coarse. You can see the checkerboard pattern on the steep material and the smooth finish on the non-steep geometry. But what about using something like waterline machining? Wouldn't that help? Well, waterline machining is an excellent way to machine steep geometry, but it's not so good for non-steep geometry. Watch this simulation. You can see that the surface finish is very nice on the steep geometry, but not so good on the non-steep geometry. Fortunately, Solid Edge Cam Pro can machine both types of geometry in one operation. Waterline or Z-level machining for the steep geometry, and a different type of machining for the non-steep geometry. Let's take a look. We're using steep and non-steep geometry in this operation. For non-steep, we're using a follow periphery cut pattern, and for the steep geometry, we're using a zigzag Z-level cut pattern. Let's change the steep angle to determine the break line between steep and non-steep. That looks pretty good. Let's take a look at the simulation of that machining path. We can turn off the display of the model so that we get a better indication of what the machining looks like. That looks very good, both on the steep portion of this model and the non-steep. Here are some questions for CheapCam. Can CheapCam recognize steep versus non-steep geometry? What cutting method do you recommend for steep geometry? What cutting method do you recommend for non-steep geometry? Can CheapCam machine both steep and non-steep geometry in the same operation? Now let's take a look at G-code based simulation. SamCam has only toolpath based simulation. In other words, what we think will happen at the machine, but we're really not 100% sure. That may not find the crashes between, say, the fixture and the tool holder. They may offer G-code simulation as an expensive add-on. In reality, for most 3-axis machining, you don't need G-code based simulation. However, If you do 5-axis work, it can save you from serious and expensive crashes. Solid Edge Cam Pro comes equipped with several sample machines that are shipped with it. Each machine has multiple controls. For example, Siemens, Fanuc, and Heidenhain. There are also custom machine tool kits that are available for an extra fee. Let's take a look at a demo. G-code-based simulation means that you're post-processing the code, and then the black box inside of the machine is being used to translate the code into actual machine motion on the virtual machine. We'll use G-code-based simulation on this multi-axis roughing toolpath. But first I want to show you toolpath-based simulation. This is the simulation that some CAM vendors use, and it's adequate for 3-axis machining, but in reality it's not quite good enough for 5-axis milling. Toolpath-based simulation is what we think will happen at the machine tool, but we're not 100% sure. Now let's switch over to G-code-based machining. This will take a moment to set up because the first thing that has to happen is we actually create the post-process code to run the virtual machine on. You can see the actual G-code data being displayed in the NC program window. And as we press play, the cursor parses through the G-code file. We have collision detection set to on, so if there is a collision, we'll see it. Hey, there it is. It's much better to have a crash here rather than on the shop floor. Wouldn't you agree? Here are some questions for SamCam. Does SamCam support G-code-based simulation? If so, what does it cost? And is their G-code-based simulation an external application, or is it built in, like Solid Edge Cam Pro? Now let's talk about selection and visual aids. This cam, that cam says, you might spend up to 50% of your user time performing geometry preparation. In other words, creating boundaries and other things that will help you in the machining process. They may have a lack of graphical helps on dialogues, and that makes learning the software more difficult. By the way, selecting geometry is a tedious process, so if you've got aids that help with that, you will be more productive and more efficient. In reality, boundaries are old school technology. Why not move up to a modern CAM system? Solid Edge Cam Pro has lots of selection and visual aids, like multiple face selection pop-ups, graphical helps on the dialogues, and you can gather information while you work. Let's take a look. Some of the great visual aids inside of Solid Edge Cam Pro include the ability to gather information while you're performing another task. In this example, we want to create a cutting tool, but we're unsure of the size of the smallest corner radius in this pocket. We can very quickly go check the size of that corner radius while we're still creating the tool. We can check either radius or diameter. In this case, this is a 16 millimeter diameter corner or 8 millimeter radius. And now we can go create a tool that is slightly smaller than that radius. And there's our tool in the carousel. Here's another example of the visual helps inside Solid Edge Cam Pro. Pictures attached to the dialog options helps you to understand what that dialog option does and allow you to make an intelligent choice about which option to use. During face selection, instead of picking all the faces manually, we can use tangent face option to pick all the tangent faces in a particular set. That helps us be more productive. The visualization tools in Solid Edge CAM Pro are excellent. Here, we not only give you a good graphic display of what the in-process workpiece looks like, we can also perform analysis and tell you things like how much material is left on the stock at a particular point on the machine surface. We simply probe each point that we're interested in, and we get the result immediately. Here are some questions for this cam, that cam. How much time will I spend in geometry preparation before I can make tool paths? Why does your system use so many boundaries rather than selecting faces? And why aren't there graphical helps on dialogues? Now let's take a moment to talk about in-process workpiece, or IPW. SafeCam says they're very confident that stock and cutting tool crashes will not happen. But if the software doesn't recognize that stock has been removed by prior machining process, then it will waste a lot of time in error cutting. In other words, engaging cutting motion far from the remaining stock. It can be difficult to see the cutting path because of all the retracts and engages. In reality, there is a better way to track the in-process workpiece across multiple setups. Solid Edge CAM Pro has an in-process workpiece, or IPW, that follows the model as it gets machined. Since CAM Pro knows what has been cut already, there's no wasted time in air cutting. Let's take a look. Here we have a part that's completely machined in two setups. By flipping the part from one vise to the next, we can actually machine this part completely. First, we'll show the machining that takes place on the first setup. Now we'll use this in-process workpiece, or IPW, as the stock for the next setup. Let's take a look at it. There's the IPW for the first setup being displayed upside down in the second setup. And because CAM Pro knows what stock is left to machine, there's no air cutting as it efficiently finishes the machining of this part. Here are some questions for SafeCam. Does SafeCam keep track of the in-process workpiece? Will it track across multiple setups? Can I use the IPW, the in-process workpiece, to support documentation like Solid Edge CAM Pro can? Let's talk for a moment about post-processors. CAM says they offer a USB stick with over 1,000 post-processors on it. However, the data is very disorganized and multiple posts are offered for the same exact machine. Which one should you choose? The issue here is quantity over quality. In reality, you don't need multiple posts for the same machine. You don't even need 1,000 posts on a USB drive. You need one accurate post processor for each machine in your shop. Solid Edge Cam Pro has the Post Hub. The Post Hub is an online database of over 1,100 post processors. It's searchable by key machine characteristics. Access is free and comes directly through Solid Edge Cam Pro. And most of the post processors are free. There are a few on there that are part of a machine toolkit, and those are an extra charge. Let's take a look. To access Post Hub, simply choose the Post Process button and then browse online for a post processor. Post Hub is a searchable online database of over 1,100 post processors. You can search by controller family, machine manufacturer, number of axes, and units. Once you've found the post you need, downloading it is a simple button click. You can install the post, but even if you don't, it will be immediately available for your use. Many of the post processors have self-correcting functions, like this warning that tells me the program name is inappropriate and that it will be replaced by another, more appropriate function. Post Hub makes obtaining a post processor very easy. And here are some questions for CAM. Why do you have so many post processors for the same machine? What if your post processor needs customization? Can you do that for me? And if you can, what do you charge for customization? Now let's talk about market share. Some CAM vendors will try to skew their market share to their advantage. They'll say things like, most seats sold since 1983. But in reality, how many of those 37-year-old seats are still active? I think a more reasonable estimation would be to find out seat sales for the past 3 or 4 years. Most seats in use today. This number is often inflated by academic or free seats that aren't used in a commercial environment. In reality, market share isn't the most important thing. However, companies with larger market share can spend more money on improving their products, and that helps you, the user. According to these trustworthy sources, Siemens has the #1 market share in CAD and in CAM. Why choose Solid Edge Cam Pro? We have the capability to meet your needs now. We also have the capability to grow with you. We represent great value. For example, adaptive roughing is included with every 3-axis seat. Frankly, it's superior technology at a competitive price. Solid Edge Cam Pro is a professional, modern CAM system. As we saw during this demo, steep versus non-steep, follow me IPW, G-code based simulation, selection and visual help aids, and there are graphical helps everywhere. The Post Hub has over 1,100 post processors and machine toolkits. And we have the market share to support your growth. Thank you.